Welcome back. We are here just where we left off. It wasn't only a minute ago, but it was fairly recently where we were modeling this table, and we did what I call the brute force approach to modeling, and I said I would come back and show you the more efficient way of doing it. Now, the more efficient way isn't actually going to save us a lot of time in building this table, but if you were building a more complex piece, it could save you a huge amount of time. So I think it's a good idea to learn how to do it, and then make a very clear distinction. If I was modeling this table, I would probably use the brute force approach, because I might save 2 or 3 minutes by doing it the other way. If I was, however, modeling a very complex piece, say if it had 20 or 30 drawers in it and lots of very complicated joinery, maybe it would save me an hour or 5 or 6 hours if I was doing something really complex, and in that case, it might be worth it. Now, I'll just close this one that we already have, and we're going to start from scratch. In the same way that we started before, we'll make sure this is in perspective with orthofaces. We're modeling in imperial for our American friends. And I will say start a sketch, and this starts off the same way. I am going to draw a center point rectangle, looking from the top. I will hit D for dimension and give it some dimensions. We'll use exactly the same dimensions that we used in the last one, 61 by 27 inches, which is fairly standard for a table, dining room table. And this is where things are going to be a little different. I'm going to draw a leg. And I'm going to draw a center guideline from here across. And I'm going to draw another center guideline from here across. I'll make those two guides by clicking and hitting X. I will hit equals and make the two sides equal to turn this into a square. I will say that they are 2 inches from the outside edge by typing it in. And I will again dimension this at 2 3/8. And now they are all fully defined, including our guidelines that are going to the center. Note I didn't draw the guidelines through the center because I'm not actually going to be mirroring any of these components. What I will, however, do is find the middle of our guidelines and draw a center point rectangle just like we did before, but I'm only going to draw it halfway, and that is where this distinction starts. I will say equals, and like we did before, if I click and hold, I can pick which one. Know that it will allow us to pick all the ones that are in that line. Those are now to depth, and I will make those exactly 11/16. 11/16 that I used for that? Yes, 11/16, I believe. And oh, that's why it looks so wrong. 1 11/16 was the dimension that I used for those pieces. I don't know why it didn't take when I put it in before. Now, these are in the wrong place, so I'm going to pick the outside edge, say coincident with, and they are coincident with the center. I will do the same thing with this outside edge, coincident with the center, and it will go all the way to the center. I will now say finish sketch. Now note, I didn't create all the other pieces because I really don't need them. We'll start by making the tabletop the same way as we did before, selecting all of it and typing in 1 1/16, I believe was the thickness we used. It might not have been, but it's the right idea. We'll say new component, and our component we will call top. It's always a good habit to get into naming the components as you create them, and we'll hide it. We'll turn our sketch back on, and we are going to start by modeling our legs. We're just going to model one though because we've only got one, and I believe we made it -28 inches. We will say new component. It's nice that it is telling us that we turned on Do Not Disturb. I'm not exactly sure how that happened because I didn't touch anything and my phone is sitting right next to me. But I'll pretend that that was supposed to happen because Do Not Disturb was supposed to be on already. So I'm going to make these rails -2 3/8, And instead of joining them, because that's not useful, I will say new component. We'll call this one legs, even though there's only one in it. And we will call this one rails. Now, at this point, last time, we turned off our sketch, so we'll do the same thing. But instead of having 4 rails and 4 legs, we have 1. And what that allows us to do is come in here, and we are going to make some joinery. On the edge of our leg, we are going to cut a tenon. That's not how we did it last time, is it? Well, this is how we're going to do it this time. We're going to cut a tenon in by drawing a line and selecting that line and making it a guide by pushing X. We're going to create a center point rectangle. We're going to make it a center point square by making the sides equal. And I'm going to tell it how much of a shoulder there is going to be, and we are going to say it is a 3/8 inch shoulder. Now, I'm going to have that go up, and we will turn our tabletop on, distance to object, pick the top, and say join. We'll turn the top off again. Okay, and that has created that tenon on top for us there. We are going to do the same sort of joinery on these edges. I honestly can't remember what joinery we used last time, but we'll do something that looks fairly nice. What I think we're going to do is we will make a nice through tenon on each. We'll do 2 through tenons on one and 1 through tenon on the other, and that should be relatively easy for us. What I'm actually going to do is I'm going to do square through tenons. So we will turn off our legs, which includes that nice tenon. I am going to open it up here, and I will draw a guideline. If we hit X before we draw it, it'll work the same way. So that's that. And we will draw a center one as well. And I'm going to use a little trick that I sometimes use. I will draw a center point one. Oh, we need to make sure it's not doing it as a guide. We will draw a center point rectangle. We will draw another one up here. We will draw one down here. I could mirror them, but it's not really necessary. I'll turn on the guide. 1, 2, 3, 4. So now I have 4 guidelines. I'm going to make those pieces equal, so they are all squares. And I am going to go in here and tell it I want those to be 3/8. Now, they are in rather awkward position at the moment. I can move them up and down, and that's great. I could do it by eye. What I really want to do is have them evenly spaced. So the reason I drew those extra lines is that those are all going to be equal. And now I have those evenly spaced. I don't even need to know what this dimension is. I know they are evenly spaced. Now the problem with this is, as you have already been able to see, that doesn't give me the spacing I need. So we're actually going to just pretend we didn't do that. We're going to go back and call a mulligan on our dimensions. I will pick this one and delete it altogether, including its center point. Now, if I pick the top one, I can mirror it across the center line and hit OK. Now we know where the center one is. I think we have all these equal, right? 1, 2, 3, yes. They are equal. Very good. So they are all 3/8 inch. And the only thing I need to do now is tell it how far from the top this is going to be, and I'm going to make it 1/8 from the top. Now, that means that if we were going to do this as a separate tenon, that would be awfully close to that top edge. But in this case, it's not really that close to the top edge, and there's a huge tenon in the leg that is going to give us the stability on top, so it's not a problem. We'll say finish sketch. We're going to draw on this other one here. We will draw a center line. We'll draw another center line. Whoops, that's not in the center. We'll take our line tool, find the actual center, and now we will draw a center point rectangle. We'll make it a center point square by making the two sides equal, and we're going to use our mirror tool to mirror it across. By double-clicking, it selects the whole thing across that middle. Now, if I say I want that dimension to be 3/8, just like the other one, I can look over here and see that what I really want to do is have a space between these two here. And if that is 3/8, what I actually want it to be is a 1/2 inch between the two, and now they will not conflict with each other when they go all the way through the leg. Now, if I say extrude, I want to extrude these to the outside edge. Now what we're actually going to do is we're going to make them go a little beyond the outside edge. We're going to make them go a 1/16 of an inch out. I will say join, turn the leg off, and hit OK. We're going to go in here and hit extrude and do exactly the same thing. Where has it gone? You can peek underneath. And we will say distance to object, turn the leg on, pick that, say we're going to go a 1/16 of an inch proud, and say join again. If we turn the leg off and hit OK, you can now see these three are going to go through. The two in the middle are going to go through no problem at all, and that will go through the holes in our legs. Now, if I say combine, I'm going to turn the leg on and cut the leg with these other two pieces. And now if I turn the rails off, I can see I've already cut the joinery in my legs. So I've got the leg joinery going into the top, and I've got the rail joinery going into the leg, and I've done it all on one corner. The only other thing that I need to do in here is we had some internal bracing. I think we had longitudinal internal bracing, did we not, in the other table? I can't remember. But I think what we will do in this case is we will have some cross pieces. So I'm going to go in here to our first sketch, and I am going to say that I want to join from, yes, that's right. How are we going to join that across the center? We'll do a half lap. We'll do a half lap, so we'll do it after. All right, just thinking on my feet here. So we now have all the tenons joined in. There are no floating things lying around. So what we will do is we are going to copy this leg, and we will copy it across the center line. Right-click and hit repeat, and copy that leg. Remember, we've already got the joinery cut in, so we don't need to cut any of that joinery the next time. So I now have that already in there. We've got these, and you can see we've got all our mortises cut, completely finished. So I'm going to say repeat, and I'm going to mirror that half the long stretcher, and I'm going to mirror it across, and it will join. So now I have our long stretcher as a single piece, and I will mirror it again across the center. So now I have two long stretchers. I'm going to do the same task with this short stretcher and mirror it across the center. And then I'm going to mirror that now completed piece across the center in the other direction and say new body. So now I have that piece already in place. While we're at it, we're going to say combine, and we're going to cut the top with our 4 legs. We didn't do that with the one leg because it didn't make sense to make one hole and then have to go back and do it again. But what we're going to do is we have it going through the top of the table now, which I think works out quite well. If we hit A for appearance and change to having our legs in this walnut, not that we need to make the legs out of that walnut, but it will show us that the end grain is coming through the top of the table. And that will work quite nicely. It's very nice and decorative for us, actually. So the only other thing we want to do here is have our cross bracing on the bottom. We did straight ones before. I think it's more interesting if we model something similar, but not quite exact. So what I'm going to do is I will hit project, and I'm going to project the legs and the rails. Project is just copy the dimensions from these objects. So all I want to do is make it so that I can use these as anchor points for lines and curves and such when I am in this sketch. And I think that's very, very useful. So what I actually want to do is I want to draw a stretcher that goes from one side to the other. I will draw it in one direction. We're only going to model one of them, and then we're going to copy it. And we now have our cross brace. If I hit Finish Sketch, and I select that piece, my apologies if you can hear the fire trucks driving by outside. Seems that the whole city is on fire. That's the fourth one I've heard since starting this class today. And I'm going to say to object, and it is going to be the same depth as my outside rail. And we'll say new component. We'll call this brace. I think that worked out quite well, right? It's not bad. So what I'm going to do is I'm going to turn off the legs, and I'm going to go and take a look at this at the end of this brace. I think that looked quite good. Not bad. Not bad at all, right? Let's deselect it, and we'll get rid of our rails as well. So I can see that I have this cross brace here. Now, how are we going to join that in? We're actually going to use dowels to join that in, and we're going to use the dowels that are exactly perpendicular to our brace itself. Now, what I want to do to make that happen is create a plane that goes, let's see, what have we got here? Plane through, along path, plane, tangent plane, plane at angle. What we want to do is we want to find out what that angle is exactly. So we're going to take this piece, we will inspect it, and we will say, what is that angle? That is 69.6 degrees. So what I want to do is construct plane at angle, and we will pick this, and we will say that it is minus 69.6 degrees. So we should now have a plane that is exactly perpendicular. Now, if we were going to do integral tenon joinery, we would be able to do it without that. We could just model right on the side. And I guess the question would be, do we want dowels or do we want internal tenons? And I will talk to you for a moment about how to do either one. Let's turn off the brace. Now we have this perpendicular plane here. And if I look at the brace, I would be able to model now. Right on the end of this brace, I would be able to create holes for dowels that will go into our legs. And I think that's what we'll do. But let's just take a look at how we would do the other way first. If I scroll over to the side of this brace, if I wanted to make these tenons that are constructed going out through the edge, let's just do that. We talked about how to do the dowels. Let's do the tenons, and I won't talk it through. I'll just actually show you. All right. So, new sketch. We'll do a new sketch on the side of our brace. Where does it begin? Well, we're going to look over the top of our brace and see that that is actually inset somewhat. So when we create our tenons, we don't have to worry about the fact that it's going to overlap. We just need to make sure it overlaps enough that it's on the inside. So I am going to say create. No, I'm going to say I'm being silly about this, and I shouldn't be creating as a sketch on that side. All right, where's the top gone? Rails, brace. Sorry, I got a little distracted by yet another fire truck going by outside. So I have my construction plane. I am going to create a sketch on that little construction plane. I am going to project the outside of our thing. We don't need that. We just need the outside face. We need the top and bottom, and that will do it for us. So we are modeling on that. I'm going to draw a rectangle to signify where those pieces are. Where have they gone? Okay, I will create a rectangle that is exactly those pieces. I will make the whole thing a guide, so we know where it is. I am going to make a center line down the middle, and on that center line, I am going to draw another line, side to side. It's good. Not sure if I need that one, but for now, we will draw a center point rectangle. I am going to give it a dimension. Hit D for a dimension. From the top, we are going to make that exactly 3/8 of an inch. And from each side, we are going to go in 1/8. It looks like we are not necessarily on the center, so I am going to say coincident between this and that guide line, and now it is there for us. All right, so we have that piece, and we are going to go from that tiny little rectangle. Instead of the profile plane, we're going to say from the object itself, and we are going to go exactly 1 inch, negative in this case, and we will say new body. Now, if we look at it, what we have here is a tenon that is going right through from the edge. I don't think we've done that right. I think we've made that an angle. My bad. Edit feature. We're just going to go from the profile plane, and we're going to give it a distance. We'll just stretch it right out through the end here, and we're going to say minus 29.5, and that's going to be exactly straight. There's a few ways you could get around that, but I think that's an easier way to do it. We'll say we want it to be symmetric, and we will say join. And we have now created that. Could have done that with dowels, same way, but I think doing it with the tenons will be a little stronger. Next thing we're going to do is we are going to mirror that across the center line. All right, very good. I think I just told that to join. This is what happens when I'm modeling early in the morning. I want it to be a new body because we are actually going to cut these so they are half laps. What I want to do now is create a midplane between the top and the bottom, because we're going to be cutting these vertically in half, or at least we're going to cut one of them vertically in half. Now I am going to cut this one body, and I'm going to pick the outside faces. Better turn off that so it doesn't get confused. I'm going to pick the outside faces of this other one to cut it with. And now we can see that we have this center piece. I'll open this up and show you. We now have body 4, body 3, and body 2 are 3 separate pieces. Now, if I turn on this plane that goes through the middle, body 2 is which one? Body 3, body 2, body 4. Body 2 is the one that I want to cut. So I am going to cut body 2 with this plane, which is going to divide it right in half. And I think we have created, where have we created it? We'll turn this off. We're going to get rid of the first body altogether, and I want to get rid of just the bottom half. Now if I go back in here and hit combine, hit join, and I will join 1, 2, 3, and we have the top piece of our half lap. We will take the bottom, hit combine, and cut. We will cut the whole piece with the part that we've already cut the half lap into. And now you can see that we have the bottom half of our half lap and the top half of our half lap. Those are already in there now, and that's no problem. Now, in terms of the legs, the only thing we want to do is do exactly the same thing. We will cut that, repeat it for the next leg, repeat it for the third leg, and one last time for the last leg. And now, if we get rid of our braces, you'll be able to see that we have a nice little mortise for each of those right in the side of each of our legs, and those mortises should not conflict with any of our joinery. If they do, you can always go in and take a look and shorten those mortises to make sure they don't. But it really doesn't make that much difference. You'll be able to see that when you look at the model. In this case, it should go within about a 1/16 of an inch, and it shouldn't overlap, if I've done my math correctly, which is not necessarily a given since we are doing this in imperial, so they might actually conflict, and you might need to shorten those a 1/4 of an inch or so to make them work. But that's not really that big a deal, and the whole concept should work fine. All right, so that is the other way that you can do it. If you model things in their smallest components, and then do the joinery, and then flip them around over the middle, it will save you a considerable amount of time if and only if the model is actually complex enough that it warrants all that extra thought. All right, so that is the second different method for modeling this table, which I think might be a little different from the one we did in the last class, but looks pretty much the same from the outside. The joinery, I think, is a little different, and we have these neat little cross braces on the inside, which add a little bit of flair to the table. So if you've liked what we are doing here today and in our other classes, please hit like. If you don't like it, of course, you can hit dislike, but please leave a comment either way. Tell us what you got out of this video or what you would have liked to get out of this video but didn't. If you don't mind, please subscribe and share with your friends who might be interested in learning about Fusion 360. This was in response to a series of questions I've had this week from people who have watched some of the videos about the difference between why sometimes I model things in a quadrant and sometimes I model them as a whole piece. I use these two methods interchangeably, usually whichever I'm feeling is useful for the project. The bigger the project, the more complex the project, the more likely I am to do it this way, modeling things as individual pieces and then duplicating them after I've done the joinery. This is not really something you have to worry about if you are constructing things in metal or in plastic, and the thing is going to be either molded or welded together. When you have to have complex joinery for wood, or, I mean, if you're doing it in other materials and going through with this type of complex integral joinery, the same would apply. But mostly this is just for woodworkers, that we want to create the way things connect together, the joinery. And it's a lot of the time easier to do it on one section and then mirror that section with the holes and with the pins already cut than to do it after. But of course, a lot of the time you're probably going to want to model something and you'll do the joinery later once you get the visuals to look right. And often once you've showed it to a client and they've approved it, if the joinery is going to be hidden, you don't have to worry about modeling it, and you might have to give them 10 proposals before they actually sign off on one. So why take a few hours extra to model all the joinery if they're never going to look at it and you're not actually going to build it? So it comes down to a question of pick the method that you think is going to be most efficient and most helpful for the model you are specifically building. Anyway, thanks for joining us, and I hope you have fun today in your shop and modeling for the things you're going to be building. Come and join us next time when we are going to be modeling something else and answering a few more questions about using Fusion 360. Have a great day.